Okay.
Let's quickly do some practice.
But
So I'm recording the section. So we've looked at how to use data frame. So data frame Lawa. So what we wanted to do today is for the student to be able to practice and develop their own data frame. Understand? So like I provide an example. So the student has to develop a table by themselves using data frame. That is what we wanted to do today. But I think they will join as we proceed. So, Najim, are you joining with your laptop? Yeah, Najim, are you joining with your laptop?
are you with me?
Yes, I'm with you, Prof.
Yes, I'm with my laptop.
Okay. What about Najim? Is he joining with his laptop? Najib, so if you are joining with your laptop, want to say how you can form a data frame. That is the idea of today's
No,
class.
I'm using phone, sir.
Oh, you are using the phone. So want to say
No,
how
I'm
you
using my phone.
okay. Wanted to see how you can form a data frame and also add more
No, I'm
columns to
using
it.
phone.
Is all right, is all right. So we'll quickly go through the class again.
Okay.
So how to form data frame. So before we go into data modeling, so we've seen how to save data, but let's quickly go through the class again, see how to construct our
Okay.
data frame. So how you can construct your own table, how you can get your own data from your table without and add to a table. You understand? So that's what we want to do, constructing of a data frame. Construction of data frame. So we've looked at how to construct data frame, and so say for instance you have a data. Say your data is so you have a data, so you can construct a data frame using a dictionary. A dictionary takes an order pair, say um, say name. Let's call it first. You take a data frame. So let's say this is the name, and the name is list of some people, list of names. Say the list of names are John. The other one is let's say the other name is Sarah. Let's say the third person name is Bola. Yeah, and okay, let's just leave it at three. And you remember it's a dictionary, so you separate each of them with a comma. Then the other name, the other one is let's say is age, so it's a string. Then it takes a pair of the age of John. John is let's say 14 years. Sarah is let's say 12 years, and Bola is let's say Bola is 23 years or 25 years. So let's say it takes their city. So don't forget your comma. Okay. So you take their city. So let's say these people are residing in so city, they are residing in let's say so it's a list. So put them in a list. So the city is also a string. So city is let's say Calabar. John stays in Calabar. Sarah stays in where? In Lagos. And Bola stays where? Bola stays in Sokoto. So these are the lists we have. So now we want to put this as a data frame. Okay, we want to put this as a data frame. So before you put this as a data frame, you import your library. So the data frame we are using is pandas. So you will say import what? Import pandas as what? As PD. PD is just an alias name. Okay. So you said data frame, which is df. Okay. So say your data frame, name it df. You can name it as anything, df1, df2. So we just say df. So df is what? Your PD dot what? Dot data frame. Take note of this. Data frame takes what? Okay, before then, let me run this. Let me set my system open. So let's run the environment to ensure that the environment is working before we start typing. So it's working. So now we say data frame, which is, so this is just like a variable. So this df is like a variable, just like we've been using x, y, z. So df is what? Is a variable. A data frame. So you use your alias, which is pd dot what? Dot data frame. So don't forget, data frame should be in what? In capital letter, and this F is also in capital letter. So data frame, then what does it take? It takes some values of objects, right? So data frame of what? Of our data. All right. So we do df and we get a data, right? So our data is appearing like a table. I hope you can see the screen. Now we want to add another table to it. Okay, let's say this is data frame 1. Okay, data frame, let me call this one as data frame 1. So we want to form data frame 2. Okay, data frame 2. So we have data frame 2. So let's say data frame 2 take names of some other persons which are not John. So let's get some names. So these are people who lives in let's say who lives in another state. So the names are, let's say, Ade. The other name is the other name. Let's say his name is what other names do we have? Let's say Kola. Another name of another person is let's say Joy. Another person's name is Joy. So the age of these people is they are very old. They are 46, okay, 56, 40, 45, and 55. These people live in different cities in Nigeria. Say one person lives in Ondo State, another person lives in Adamawa, another person lives in Adamawa State, another person lives in where? In Abuja. So these are where they stay. So the same idea, you create a variable called data one. Okay, this is your data. So you create a variable called data two. So and this is what? Data two. So when you run it, you have what? Data two. All right. So they have, so look at this table, data one and data two. You can see them. So we want to join the two tables together to form what? Data three. So we say data frame three will be like what? Data frame. So how do we do that? We use the keyword concatenate, right? So data frame one dot what? Concatenate. We want to join concatenate. So we want to join data frame one with data frame two together. Okay. So we use the keyword concatenate. Okay. So I think we have it somewhere. Yeah. the keyword. So say data frame 3 is pd dot concatenate data frame what 1 and data frame 2 and what ignore the index. All right, so when you print data frame 3 now, we have a combination of what of this data. So you will see that this data was added from below, right? So it was added to data 1 from below. And if you change this position, it will be like data 2. So let me just do that. So you change their position. So you're going to have data 2 at the top, followed by data 1. So let's say concatenate, so let's say data 4, data frame 4. So concatenate data 2 with data frame 1. So when you print data 4, you're going to have it like this. So it will take data frame 2 and add data frame 1 to it. So I hope you can see it so clearly. So this is how you form your table. Now let's assume you have a new column you wanted to add to this data frame 4. Somebody getting it? Okay. So, let's let's assume there is a new data you want to add to data frame 4. So for those who are just joining us, we are looking on how to construct a data frame. When you construct a data frame, say you are given a dictionary of data as this. This section is very important. That's why I'm repeating the class for the second time. So please pay attention to it. So when you construct a data frame as this, then you have what? A new data frame. Then you construct a second data as this. Then you merge the two data together to form a new data frame 3. So the first one was added from the top. We added data frame 2 to data frame 1, which makes it appear this way. And we added data frame 1 to 2. The first one was 1 to 2. So this is 2 to 1. So which makes it appear this way. So you see data frame 2 at the top, followed by data frame 1. So let's assume that we just have a new individual, okay? A new individual just come. I wanted to add this person. Remember, this is just 5 lists. We have a 6th person. So they just call us on the telephone that please, this person wants to join data frame 4. So how do we add this person to data frame 4? Okay. So how do we add this person to data frame 4? That's what we want to look at now. So you pick data frame 4. So let's assume, okay, data frame 4. No, we've said we want to add a new property to data frame 4. Say the new property is, we have age, yeah, we have name, age, and city. So we want to add maybe these people have been employed by your organization, and for this data, you want to add their salary to it. So this is how you do, you subset what? The salary. So this is what we call a subset. So salary. So we subset, you assign, okay, it also to a list. So what will be the salary? For the first person, let's say the first person is earning 1,000 naira, second person is earning 2,000 naira, the third person is 3,000, the fourth person is 1,500, the fifth person is 2,800. Okay, 1, 2, 3. How many do we have there? 6 items. This also must be 6. 1, 2, 3, 4, 5. So we are left with 1. Let's say it's 2,500 last person. So this is what the person is earning. Okay, so we are adding it to the F what? The F4. All right, so this will take the F4 with a new value. So when you print the F4 now, so we should be having a 4 columns there. Can you see? So this is a 4 column. So this is how you add a column to it. And if you want to add a row to it, what do? You do what? You 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 concatenate. Okay, you concatenate the tables together, And if you want to add a row, you subset. Any question at this point? Any question? No question? Yeah, it's clear to everybody, right? Please ask question. We're not doing magic because you'll be sharing your screen now, and you two you're going to code something like this. Abel is joining with our laptop. Wazeri, are you joining with your laptop? Jennifer, are you joining with your laptop?
No, sir, we don't have lights.
All right. So maybe tomorrow you practice what we are doing today. So tomorrow you do what? You're going to present. So up next, we want to save our data. Okay. Up next, we want to save our what? Our data. So we want to save it in a format that is retrievable, that we can retrieve it. Okay. So let's say we want to save this data now. What do we need to do? You come to this class, say, oh, um, let's say you say df what? Df4, which is what you want to save, dot what? To CSV. So there are many formats here. You can see to clipboard, to CSV, to dictionary, to Excel, to FADA, to GBQ, to HTML, Itadali, to JSON to LaTeX, to Markdown, to there are so many words. There are so many ways you can save it. You understand that? So these are ways of you can save your data. So, but for the first one, for simplicity, we are going to look to what? CSV, right? So when you do to CSV, when you do to CSV, so you use this keyword in CSV format, then inside you put your file name. What do you want to call this file name? Let's say uh, demo, demographic data. So demo underscore CSV. So let's call it demo underscore what? CSV dot what? So you must put the extension. So what will be the extension? CSV. Okay. You put it. You know what CSV means? CSV means comma separated what? Separated value, something like that. So now you have that. So then you indicate if your index is needed or not. So there's a format, there's a index. If index is needed, so you say index is what? Is false. You don't want index because it has already numbered it. So if you said index is needed, it will add another number to this. So now you can do what? So there are other things you can also indicate in there, depends on the data type you have. Okay. So now you have this, then you can do what? You can save it. So when you save it, um, for this environment, we are using the Colab environment. So you can find it in this folder. You can see a folder here. So you find it here. But if you are using the offline version, you're going to find it inside your local machine. So, but when we get there, we'll understand those ones better. But for the case of this one, so click on this folder, then you find your demo underscore CSV. So now you do what? You download. Can you see? You download. And when you download, where does it goes? It goes into your CSV file, into your download. So you come to your download here. So when you come to download here, you open it. So you discover that yes, this is your data. So we open it with a CSV file. So this is your data. So now up next, we want to import this file back into our words. We want to import it back into uh, we want to import it back into Colab. Okay, so that is what we want to do now. Import it back into Colab and use. So this is where the data lies. Okay, so normally because I have this data here, okay, I don't need to stress myself in what, in uploading it back again. Okay, but normally this is what I should have done. Come to file and I come to what, upload. Either you locate it in the drive and you upload, or upload or you import. So you could have located it in a drive, so and that will require you to mount the drive and move on. So but for the case of this data, we have it in our words, in our drive already. So it's already here. So we'll now come here, import it back because we've downloaded it into, we've saved it into this folder. So from this folder, now we want to read this file. Okay, we want to read this file that we've saved. So how do we read a file? So let me put it, how to read a file. So we've seen how to create a file, right? You construct a file. So now is how to read a file. Okay, how to read the file. Now we have a file that we've created. So I want to read this file. So it's very easy. So you create a new data frame, say df. Okay, but before you do that, don't forget you import what, you import your pandas. You want to use your pandas data frame to read this. Import pandas as what, as reading. Then you create your variable. Your df is your variable. So look, df dot what, pandas. Please read what, read read what type of file do you want it to read. So you can see now in the other time we have to save, which is to excel, to csv, to fada, to itagdali. So but now you are reading from a certain file. So it's asking, where are you reading from? Are you reading from the clipboard? Are you reading from csv? Are you reading from excel, fada, etc? So you now identify that, okay, our file is what, is csv. So we are reading from what, csv. Is this clear? So you read from csv. And what is the name of the file you want to read from csv? That is the next thing. So the name of the file is what, is demo. All right, demo underscore what, csv. That is what we are reading. All right, so we are reading demo underscore csv dot what, with the extension csv. Are we together? So this is what you read. So now we've read our csv file. So then we said print the f for us. So fine. You can see now it has read our file back to us. This one clear to us. So it has read our file. Then you can start performing operations that you feel like you want to do. Do you want to check the information? Df dot what, info. You do df dot info. All right, so it tells you that, okay, these are the variables you have. The name, we have 6 non-null, meaning that in the row or in the column of names, everything are complete. There is no null there, so they are all complete. In the rows of, in the column of age, you can see there is no null there, no missing value. All right, in the column of city, there is no null there, they are complete. So also in salary, and it's telling you that what, in the rows of column is an object. All right, it's an object. That's why Python is an object oriented programming. meaning that it sees almost every strings or everything that are not number as what as object. Then in age, you have it as what as integer, all right. And also in you can see they are integers, they are numbers. So also in salary, they are what? Integers. So you do information. Then the next thing is to do what? Is to, so these are a preliminary check on your data. So you do the f dot what? The f dot what do you want to check again? The f dot describe. So let's describe this for us. So it will only take the numerical aspect, all right? But don't forget your data frame is bigger than this. Right? Your data frame is 4 rows, but it's only taking the numerical aspect out of it because age is number, salary is number. So it only give you the numerical aspect, right? But so it only show the numerical aspect. So, but I want it to show everything. All right, I want it to show me everything in my data frame. So I want to see everything. So you do this df dot what dot describe, then you put include. There's a keyword called include all. All right, to include all. So when you do this, it's going to show you everything. You can see, but it's telling you that name, the count. How many names do we have there? There are 6. So when you go back to your table, you discover that there are 6 items there. 0, 1, 2, 3, 4, 5. There are 6 there. So he counts name as what? 6. Age, it counts it as 6. City is 6. Salary, there are 6 items. That's what they call it count. Unique, the age are unique. You understand? No age is the same here. You can say no names are the same. All names are different. So like John is not repeated twice, Kola is not repeated twice, Bola is not repeated twice. So that's why I said the unique name that you have there, they are 6. All right. So in age, there is no unique because they are NA. So they are not unique, they are numbers. So nothing is unique there. So that's why I place it as what? NA. So also city, if they are string, so they are unique. But these numbers are the same. So it's NA. So the top, like the number, the names at the top is what? What's the name at the top? Ade is at the top of the list. All right, like that. So the frequency, each of those items there repeated once. That's why we have frequency to be 1. So in the named column, they are what? They are non-string. They are string rather. So you cannot find the average of a string. You know what strings means? Just letters. So you cannot find average of a letter. So that's why you see it as what? NaN. So meaning that not what? Not available right now. So why the age? So he has calculated the average age of this. So if you add 56, 45, 55, 14, 12, and 25, if you add them together and divide it by 6, you're going to have 50 what? You're going to have 34.5 as your average. The average salary is what? 213.33. You understand? So these are the properties you can find there. So 50% of your data was found to be 50% was found to be 35. So the string column, because they are string, they are letters. So you cannot take any statistic property of it. Okay. So that's why initially the table just only give you age and what? Age and salary. But because we want to be so inquisitive, we want to know more. So we said include what? Include all. So he has shown us everything. So any question at this point? Any question at this point? So let's say I want to check the first 5 rows or the first 3 rows of my data. I'll do df dot what dot head. I just want only three rows to appear. I'll do the f dot head dot into the bracket, which will be what 3. So it show me only 3 rows, the first 3 rows. And if I want the last 3 rows, I'll do what the f dot what dot tail. I think we've discussed this last time. The f dot tail of the last 3, or let's say the last 2. So last 2 item in the row is what Bola and what Bola and Sarah. So any question? Let's say let's say what else again? Can we check again now? We know how to check none if how many null values are there, right? So let's say how many null values is there. You do the f dot what is n. So you do this, the f dot is na. You're going to have string that there is no na, right? So and you can also do the f dot what dot is na dot sum. All right, the f dot is na dot sum. We can also do that, and it shows us that these are the columns that we have there. Okay, these are the columns that we have there, and there is no NA. So the name, the role is complete, everything is complete. So, all right. So you can also use this to do some. You want to check. What's it called? What else can we check again? So if you want to check some individual statistics, okay, you can do some little maths there. The f dot mean. Let's see what you have there. So we've seen that already. So the f dot you check age, then you do dot mean. This should work. Yeah. So you can just take one of the column. You want to check for the mean of this age. So which is like what we saw earlier in the table. Is the mean of age, something like this. Okay, so 34.5, and you can take it individually to using the main function. So you can also take the f, but you can take the salary out of it. So this is what we call a subset. A subset salary out of it. You can find the standard deviation, say STD. So say STD of it to give you the standard deviation at 778 of salary. So okay, you can check uh, covariance of your data frame. The f dot what covariance. You can also check. So the f dot covariance of your data frame. Okay. The f dot covariance of your data frame, because there are strings there, so it doesn't know what to do with that. So you subset twice. Okay. So put in the first subset in the second one, because you want to take at least 2. Covariance, the formula is x comma y, because it's variance of it's 2 variance. So like, let me put that in the text. So covariance is like this. Covariance is like covariance curve of what x comma y. So this is what it does. And now this is what covariance does, x and y. So there must be 2 columns and they must be numerical in nature. So it gives us an error because there is a string. So we could not convert a string into float, such as Ade. So it cannot be converted into float. So because of that, we will now subset just the numerical column out of it alone, which is what? So which we know that there is age, and the other one is what? Is salary, right? So now you have this, and you're going to find, okay, there should be a dot here, dot covariance, yeah. So now you can see it now. So covariance of Ade to Ade is what? 40.1. Covariance of Ade to salary is minus 1,700. And covariance of okay. So we could also do some other unique things. We could do other unique things using a function called group by. Okay, we could use what we call group by. So we can just say, okay, you can see this one is like grouping by a certain property, which is age and what? Salary. So we can also do what we call group by. So let me say group by. Group by will be like our data frame dot, there's a function called group by. Okay, I don't know if I can use this group by as a variable. Let me just do, I don't know, because it's a keyword. So let me use grouped by. So then group by. What do you want to group by? By name. Maybe the name of the people we have there. Let's do group by name first and see what we're going to get. Group by name, so meaning that we should group we should form a table. We want to form a table, df dot group by. Do we have a data frame called name? What's it saying? It said keyword name group by at what I'm saying, group by group by name and let's say the salary. Yeah, let's say the salary. Let's see what is wrong. It's a group by name. Okay, name is in capital letter, I guess. Oh, name is in capital letter. You can see, so this is where data cleaning comes in. So I, in my head, I've been thinking that names in small letters. So that's why it's good. Conventionally, this is what you should have. Capital letter, small letter, and other small letter. Capital letter, small letter, capital letter, small letter. But this is capital letter all through. So it's a problem. So that's why he's saying that there is nothing like name, that this one should be in capital letter. Okay. So we'll talk about data cleaning later. But so this should be capital letter, group by name, and yes, so it works now. It works now. So you do group by. So group by name, then when we call our group by function or group by variable, so we have this. All right. So this is how we play with some little data. Okay. Okay. There is something is said. So let's say we are grouping by the mean. Yeah. Yeah. So it's giving us the mean of the salary. So This is it. So salary group by. So I want to see these people names and their salary alone. So you can say, oh, this is interesting. Bola salary is this, and this salary is this. Rather than spending all your time trying to understand how much, like this table, try to understand how much are they. Bola is earning. Bola is 2.5. So you want to just try to see. So group by. So just take it out. So group by their names and age alone. So you can also group by a list of so many things. So instead of doing just only one item, so you can do more than one item. Okay, so you can do more than one item. Say group by. So you want to create a list now. Anytime you want to create a list, so this is the standard. Because we want to create more than one item as a list, so we'll put this as a list inside. So you have this as what? Age. You have this as age. So these are the two numerical values we have in our table. You have this as what? As age. So you can see now that you have grouped them by their age. You understand that? So it comes in like a data frame as well. So this is a new data frame, and you can store this into it into another data frame that will appear in this column for you. So you can say, oh, let me just save this average age and average salary that we have. You understand that? So you can group by their minimum, by their aggregate. So you can also group, instead of saying by mean, you can also use another keyword called aggregates. You understand that? You can group by aggregates. Say, instead of saying mean, you can use ag. I think it's AWG. Yeah. It's giving me a problem. What's the problem? Okay. Okay. So it cannot work like that. So when you want to do aggregates, so it should take some things inside. So what are those things I want to take? I want to take care of the mean. I want to take care of what? Of maybe I want to take care of sum. Let's say sum and sum as well as count. Sum as well as count. So it should help us to count how many items are there. And so these are things we are aggregating together. If you also take care of the minimum, we'll take care of the minimum and as well take care of what? The maximum. So this is what aggregate does. So you can say it now. So we want to find all of this. So we have aggregates. So something like salary. So you take care of the sum, the count, how many ballers are there, just one baller, how many, what is the minimum, what's the maximum, what is the minimum of age, what's the minimum. So that is how you continue to do them. So it aggregates all of them together. So these are just some advanced thing. Okay. So now the problem now. So the problem now is, so when we have some problem now, we want to define, no, these things are predefined, right? All of these are predefined already for us, but we want to define our own formulas. Okay, just like sum is just to add up two things together, right? So like adding up two numbers. So this has been defined for us, just like sum is, or count. Sum up everything together for us. So average, things like that. So, but we want to know how to develop our own formula by ourselves, and that is what will lead us to a new concept called function. Have you heard of function before? Have you heard of the word function? So, I want to look at what function is. So you can say, I want to make this thing bold. That's why I'm putting it as a star. So remember, I'm using a font size. So let me reduce it to the first order size, and I want it to be bold. I'm putting two asterisks to make it bold. Okay, you can see it's now bold. So we want to define a new concept called function. So what is function? For those who have done mathematics a little bit, what is function? what do you understand by the word function? So we'll also be rounding up. We'll round up with function, okay? So and I just want to introduce us to function because we'll start using functions to define our own formulas, okay? So let's say function. So let's quickly check what function is. I don't know if this paper defines it, but I don't know if this paper defines it for us. Check this guy. Okay. So anyway, so Python and data analysis. So we've seen all of this. That Python, this is just about Python as a language, okay? Python is a programming language that was developed by what? By Cordova Rossi. So some of the properties of Python are being characterized by what? Being interpreted language, be portable, be object oriented. I've said this in this class. It's object oriented, is interactive. It has what? It has interface and it's an open source. Open source means that you can download it anywhere, okay? And it's easy to understand. And that's exactly what we are doing. So Python is a programming language interpreted and it's also seen as an interpreter. All right. So and it's portable, meaning that you can move it from one phase to another, you can interchange them from one program to another or one subject to another. So this is just about Python. Okay, you can read them up. All right. So how Python works. So some other libraries associated with Pythons are this. So you can read them up. And this is the history of Python. So how we move from Python 2 to Python 3. So these are some basic history of Python. Okay. So and there are open softwares where you can get it for free. One of them is Anaconda. Another one is what we are using, which is the Colab that we are using. All right. So and the Python shares, all of this. So these are just introduction to Python, okay? So how to write a code, writing Python code, exactly what we are doing right now. We've seen this in the first class, all right? So these are what you just read up. So data structure, we've seen this data structure already. So list, set, string, tuple, dictionary, DQ, and heaps. So these are data structure, but this first five, they are also known as the what's it called? They're also known as it's out of my head right now. So they are just the most frequent used ones that we have. Okay, list, set, tuple, dictionary. So they are the most frequent one we have. So this is how you define your dictionary. Okay, so and also how you get an item from your dictionary. We've seen all of this in previous classes. So how to run items in dictionary, okay? So which takes key and values, all right? So how to index. We've seen this and we've used it today, how to index. So how to subset lists, all right? We've seen all of this already in previous classes. So this is where we should be functional, what's it called? Functional programming. So this is area where we are doing how to map. We've not done all about this. So but we must know what a function is first. Okay. We must know what function is before we start doing mapping, filtering, reducing, lambda, and this composition. We have to know what this function is, all right?
And that's why
So
when
this
they hear it goes
is
operating
necessary.
in your
So how do we define our function? So let's define the function. Let's see. A function is just what? Just an order, just a way of assigning what? Assigning things. So how we assign, so there are different ways of assigning variables or how to assign variables to a certain concept. So how do we assign? So you can define your function in so many ways. So there are two important ways of defining the function. Either so you say you use the keyword. So the
There are
structure
certain
is
instance exhibits that you're
use
not
a
including like
keyword. So your
you know I'm
variable,
going to work with
you assign it to a
because
keyword
all
called
like
function.
must over private
So
the way to actually know you're going to do the way you get it out.
use
As
the
you begin
word
to do
define.
this, train your
All right.
mind now.
So
But
define.
train your
So
mind now to have mastery. You know what?
someone should
Still
know how
what
to
your
reduce
private
that.
stuff must be how to stimulate. See, until you and I can learn that
Wait
as
a
you're making
minute.
money in your 9 to 5,
Your noise
you must
is your
have this
background
thing.
is making noise. Please help us to reduce it.
I cannot allow you to repeat it in this technical immediacy. You cannot have provide for certain needs. You cannot save and you cannot get before. But you and I can go to work with the idea that, oh, I
Reduce
am going to
your.
do.
Thank you very much. So now you use the keyword define. All right. So use the keyword define. Def def to define a function. All right. So you said define. So but you have to put the function name. What's the function name? What does this function want to do? You want to add. So add numbers together. Add what? A comma B. To add two numbers together. So you define A and B. So it's a compound statement, like I have said. We have simple statement and compound statement in Python. So this is define A comma B, which takes what? Which use the keyword. There is a keyword in Python called return. All right. What do you want it to return? Return A plus B. So to return A plus B for you. So, and where do you want plus B? So where do you want your results? Where do you want your result to be? So your result will be outside your function. So your result will be outside the function. So what will be the result? So let's call this as results. So result should give you what? Add. So now let's quickly go back again. So this is called, are we together? All right. So this is called your function definition. All right. This is your function definition, and this is what you use to call your function. So when you come outside of your function, what you are doing is calling. Let me put it as a comment. You call just like you call your siblings. So call the function. So here you calling the function, or you call the function. But in this first place, what are you doing? You define your function. Let me make a comment. So define function. So this place, so you can see now, so this is function definition. This is your function calling. So you define a function A and B, you say return A plus B to you. And what could be A and B? Can someone suggest for us? A and B. What do you want it to be? Let's say 3 and what? 3 and 5. So what do? You print your results. So you print your results. So when you print your results, what do you have? We should have 8, right? So 8 as our answer. So this is function. So all these values that you can see here, mean, sum, count, add, minimum, maximum, age, count, all of this is how this function were defined that we are using in our analysis. Okay, so this is how you define it. So now we will learn how to define function very well before we proceed with our analysis of data. So now we've defined the function of addition. All right, so who can define function of multiplication for us? So let me just copy this and paste, and please, Jennifer, tell me how we do multiplication. Are you there?
Yes, I am
So
here.
what do you think I would change here to make it multiplication?
Uh, yes, that add.
Okay, we turn it to what? We just name it. Can be any name, right?
Mul-
Not
Yes.
necessarily multiplication. Let me
Eh,
call it, let me just call it, let me call it your name, Jen. Sorry, I'm using your name. Let me just use your name,
yes.
okay? You can call it Jen. So, and what else do you think I will change?
That plus sign.
To what? Multiplication.
Yes.
Yeah. So,
Yes. Then it comes to results.
so I come to
Results you
results.
put multiple.
I'll put Jen here because I use Jen to
Mul-
define it, right?
okay. Okay.
I use Jen to define it,
Okay.
and I can also use, so 3 multiplied by 5. What do you think we should have? 15.
15.
Yeah. Good. It works, right?
Ah,
Good.
yes.
But for the sake of convention, not to misuse letters, okay? Or for someone who will be reading
Yes.
your program, you can even say, "Oh, Jen," you like, "Oh, what is Jen? What is Jen?" Until he thinks so very fast. So you can use a conventional word, which is mul, okay, which is known by almost everybody. Say mul means multiplication. So when you run this, it does not change anything. Okay, thank you. So who else is telling me how to do division? I'm copying and paste. Someone should tell me what I will do for division now. Who is there? 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 Okay, for division, I will use the keyword div, just like it started with division, right? So divide, I will change this thing to what? To divide, okay? Use this keyword divide, and I change my function to what? Divide. So, and we want to do 3 divided by 5. Let me just say 10 divided by 5, okay? So 10 divided by 5, so to return 2 for us, all right? So this will give us 2. So there are two different types of divide, okay? There are two different types of divide. So you can use this as your divide, and you can use double slash as your divide. So you can do it like this. So, so this one returns integers, right? And this one, so let's see, good. So this one return float. If you look at your answer here, this is a float, all right? So let me show you. Someone want to join? Oh, so in next 15 more minutes. So we'll wrap up with a function, then you can go and practice more. So we've seen how to use how to define our functions. We've seen how to define different types of functions of addition, multiplication, division, all right? And also let's look at, so in this case, the first case with single division, so it returns a float. So when you check type of, there's a type of results here. So when you do the type of result, what do you have? It's going to tell you that this is a float. So let's say print type of results. So it's going to return float to us. So let's do it this way. So let's put, because we are using double line. So print results. So it's going to print the results and tell you that this is a float. So when you use a single line in your division, single forward slash means it returns a float. So when you use a double line in uh, your division, your double slash, so this tells you that, let's say, print results. So this will return what? This will tell you that you have an integer. So that's the difference between a single line and a double line. So you've seen how to create a function. So let's create other functions. Let's say a function that we return power. So you define. So let's just copy this and paste. So let's call this one as what? Power. So power of A and B. So you have to define power, you use what? Star star. So A double star B. So meaning that what? It should return exponential power. So meaning that we print power of what? A and B. So let's say 2, power of 2 and 3. When you print your power of 2 and 3, meaning that 2 to the power of 3, that should be like 2 multiplied by 2 multiplied by 2 in 3 places. That should give us what? 8. Yeah. So, and returns what? Okay. Yeah, and the type is what? Integer. So this is how to define a basic function. So you must understand the operation precedence. Okay, they are very important. So these operators that we are using, operator precedence. All right, so they are very important. So meaning that how are operators, how are they arranged in terms of hierarchy? Okay, which one? So which one and which is higher? So you must understand operator precedence. So our operators here are, for instance, are addition, right? So in case of Python, operator precedence follows the order of what? Bedmass. All right, just like in your mathematics, it follows the precedence of what? Bodmas. So, but in this case, it follows the precedence of what? Bedmans. Okay. So we can see that in the Python book as well. So let's check the Python book. We have so the data type. Yeah. So you will see. Okay. So um so they follow order. So Bedmans means what? Parentheses are taken care of. Okay. So this is what you do. So in, this is a markdown environment. So this is parentheses. So parentheses is taken care of, followed by what? Followed by exponential, exponent. So like something like power, something like this, exponents. So yeah. So followed by uh, division and multiplication. They are on the same level. Then followed by arithmetic, which is addition and subtraction. They are also on the what? They are also on the same level. So there are other operators, which is like Boolean. The other operators like bool. There are other operator Boolean. There are other univariant operators. Others. So this ones. So let's just talk about the basic for now. Okay. So there are others and others. Yeah. So there are others. So for now, we'll just be considering uh, these first three. So now, so when you are doing some of your operators, or when you are trying to run some programs, so you must take cognizance of parentheses, division, exponent, multiplication, and things like that. So let's look at an example. You know how to create a new cell? So this is how to create a new cell. Yeah. So let's take a good example of maybe things with parentheses. So maybe your x, you define a function. Okay, define a function, let's say addition. Oh, before we do that, let's say you want to add these two numbers together. X is equal to maybe 2x 2 multiplied by 5, let's say plus, yeah, plus okay. So when you want to do this, this is what you are saying, that what is in the bracket will be taken care of before addition. If you look at the PEDMAS, bracket is being taken care of before addition. Yeah. So what is in the bracket will be done first before what we have outside. So this will give us what? 20. So but in a case where you have no brackets, so let's see how Python will recognize that. Let's say there is no brackets. So you have something like this. So it will also attend to what? Multiplication, because multiplication precedes what? Addition. So this is the idea. So but if there is bracket, it attends to what is in the bracket before addition. So when there is no bracket, multiplication precedes what? Addition. So this is just the idea of what? Of your operation, which does precedence. So that is how your Python sees operators. Any question? Any question? So up next, we'll look at how to use the library called NumPy. Now we've seen the library of pandas, right? We've seen how to use pandas. So now I want to see the library called NumPy. So it's a very interesting library. So and how to use NumPy. So how we can use our how we can use the NumPy library. Okay. So the NumPy library help us to handle mathematical problems. Any problems that involve some little mathematical. So then, because as you continue your journey in data science, you're going to be using Python NumPy more often than any other library you may think about. So like we saw in our book, so let's go back to this our book. So NumPy help us so in chapter 3 of this book, so the NumPy library, okay? So it's a scientific package that help us especially in data analysis with what? With a lot of mathematical problems. So that is what the NumPy help us with. So you can look at the history here and you can look at how to use them. So but in our library here, or in our Colab book here, it's easy to use. Instead of doing all those installation in Python, because we've not started using the offline version. So the online version, all you just need to do is to do what? Is to import. So in this Colab, you are an importer, okay? So you import NumPy import NumPy as what? As NP. All right. Just like pandas as what? PD. So also the NumPy library, you import it as what? As what? NP. Okay. So now you can define a simple NumPy. So NumPy help us to create arrays. Know what array is? Array is just like an ordered. So it's just like they are just similar to matrix. All right. So they are just similar to matrix. So and so let's just create a simple NumPy array. Say some array. Let's say array one is like let's say np dot what dot array. All right. So and it's a function. Then you put it as a list. So let's say the array is what the array is. Okay, let's just define a very simple one instead of going far. Let's define arrays of zeros. So zeros, zeros of array. Just use your np dot what dot zeros of array or the zeros. So you not determine the size. So what will be the size of your array? Say 2 comma, let's say 3 comma 4. So when you print zeros, so you just have this, just like an array of zeros. So you can also print an arrays of 1. So instead of saying zeros, say ones. The arrays of 1. So we just contain ones, right? So let's say arrays of 1 is 2 comma 2 comma 3 or 2 comma 2 for instance. Oh, sorry, I'm printing zeros instead of ones. Yeah, you print 1. So you can do 3 comma 2. So it's going to give you 3 rows. So each of these represent a row, a column. So it's column, rows and column, rows and column. So 3 rows, 2 columns. So don't forget, it is row by column. So let me put it here. So your array takes rows and column. So your array take rows and columns. So that's your NumPy uses arrays of rows and columns. So you can also determine what we call and let's say an identity, an identity, say an identity array. So use the keyword npy dot what dot eyes of what the eyes of maybe 4. So it's going to create a single column array for you. So when you do IDY, so you have an identity column. So where every other element has zeros, but the diagonal is what? Is 1. Alright. So you can define your own array. So these are predetermined array. So you can determine your own array now. So let's create an array of let's say our array 1 is like what? Like np dot what? Array. So your array in the first column, what do we have? Let's just say a single column array. So it contains a list of 1, 2, 3, 4, 5. Yeah. So and when you print array 1, what what do you have? So you have your array. So you want to print a two-column array. So you can print into this way. A two-column array, say array 2 with this is just a single column, but array 2 with 18 rows. So let's make it very small. Say 1 on 2. Then another array is what? 3. So you put them as a list. Alright, so this is how you use your NumPy to create your row. So this is a two-column array. Okay, so you can do some other things. So let's really know the size or the shape of the array. So use the keyword array2.shape. All right, array2.shape is going to give you say brackets. So let me print this. Let me print this. So yeah. So the shape is what? Is 2 by 2. That's what it's telling us. So after printing your array, then it tells us that the shape is what? 2 by 2. So we can put a comment. It says print. Let me use the keyword. Okay, it's okay. So it tells us that the shape is what? Is 2 by 2. So you can check the size. You can also do array2 dot size. Let me put that in a new column. Instead of doing shape, you do size. So tells you that there are what? 4 elements in that array. Okay. So if you check array 0 or array identity, which is the height of this. So what will be the size of this? You can think about that quickly. What will be the size of this 4 by 4 identity array? So the size will be 16. Look at it. 1, 2, 3, 4, 5, 6, 7, 8. So they are 16. So that's how to check for the size of an array. So, and what else you can check again? So you can check the data type, just like we are using in the list or in the other ones that we use, we are using type of. Okay, so you cannot use type of for this one. So instead of saying type, so if you do type of, let's say type of what? Type of ID. Okay, it gives us that this is a NumPy n dimensional array. Okay, so you can also do that. So you can also do it in this form. You do your array, your ID dot what? Dot d dimension type array. Use dimension type array d type to do that. So when you run that, so it's telling you that most of the items there they are floats. If you look at them, 1 point, 0 point, they are floats. So it gives you the type. So if you check this other one, array 2, look at array 2 data type dot d type. So this type they are what? They are integer because we just define 1, 2, 3, 4. Like this 1, 2, 3. Okay, 1, 2, 2, 3. So they are what? Integers in what? Data 2. So lastly, we can transpose our data. So that's where we're going to end it. So let's transpose our array. So array 2 dot what? Transpose. So this will help us to transpose our array. And you're going to have 1, 2, 3, 2 compared to what you have initially. 1, 2, 2, 3. Yeah, 1, 2, 2, 3. 1, 2, 2, 3. That is what for today. So you can read up on how to slice an array. Okay, array. Let me put that as a topic. array, indexing, and slicing. So just like we can slice our data frame, if you remember, we sliced our data frame the other time by taking the head and the tail out of the data frame. Yeah, those are data frame slicing. So also you can slice your array. All right. So so slicing your array. So this is a bit complex, but you just need to be careful when slicing your array. All right. So let me just give us one example to end up the class. So A arrow is a 3 by 3 array. So A arrow, which is your array, is equals to NP dot what? Array. So you open the bracket, right? Array comes with a bracket, then you put it as a list. Then what list do you want to have? The list is what? 1, 2, 3, 4, and comma. The other list, which is the other column, is list of what? Let's say 5, 6, 7, 8. Let's say the other column. This is a 3 by 3 array, so it's 9, is a 10, 11, and 12. All right, so this is your array. All right, so this is your array. So if you do a arrow arrow dot size, it's going to tell you that there are what, 16 elements there, right? And 12 rather, 3 times 4, 12. Yeah, there are 12 elements there. So you can print a arrow arrow. It's going to show you your array for this. So you can do array dot transpose. So you can say, so array dot transpose, which gives you the transpose of this 1, 2, 3, 4. So you can transpose it. So you can do array dot slice now. So if you want to do array dot slice, it's similar to the way it is being done. So you want to slice the 0 rows. Okay, element in the 0. So you're going to guess just only one item. So sorry, this is indexing. So indexing, what you are doing now is indexing. So it tells you that there is only one element in there in the 0 rows. So let's say you want to check for the index. Indexes with 1 and 2. That is the first row, the first row, second column. That's where you want to pick an element from. Yeah. So this is in the first row, second column, which is item number 7. So because it's 0, 1, and 2, you can see it. So which makes it 7. Now let's say you want to pick from where now? From the entire second row. So list the entire second row for us. So what's our second row? This is row 0, this is row 1, and row 2. All right, so this is your row 2. So if you pick the entire row 2, you're going to have the entire row there, which is 9, 10, 11, and 12. So which is the entire row 2. All right, so that's how you index your array. So also you can slice your array. So let's say you want to slice a particular part of your array. Say you want to slice from the beginning, from where? From one, from the beginning, take from the beginning in the first row by what? By all the rows between 1 and 2. Yeah, to take away the first row and give you all the first row and the other row. So that is what we have here. So slice it. So 2, 3, 6, 7, 10, and 11. So it's going to just take away the first row, then take it from the second and the third row, neglecting the last row. So this is how you slice your array. So also you can so just play with all these little things. So you can also slice your array by taking 0 words from the index 0 to index what 2 and neglecting the what the last row for you. So it will just slice the first 2 row for you. So first 2 row, then 2. So this is how you slice your array to get a very nice You can also perform some mathematical operation using those functions we have. So some little mathematical operation about it. So what are those mathematical operations you can think about? Mathematical operation, mathematical operations. So mathematical operations we can think about. So you can do your array. So from your array now you can do what? What can we do? We can find the mean of the array. np.what.mean of what? So, because all of these are what we'll be using as we proceed. So what will be the mean of the array? So the mean of the array is 6.5. All right. So you can find the media of the array. Do np dot what media media of the array. So media, you put it inside the array. Look at the array we are talking about. This array, AAR, this 3 by 3 array. So that's what we are talking about. So you find the media of your array. So media is also 6.5. So you can find the standard deviation of the array. np dot what? Standard deviation of your array. So the standard deviation is 3.465. You can find the minimum and the maximum of the array. So do np dot what minimum of your array. So minimum is like the minimum element you have in the array, so which is 1. And what's the maximum element, which is 10. So you can np dot what dot maximum of your array, which is arr. All right, so the maximum of your array is what? We have 12. Yeah, 12 is the maximum number. So these are some basic operations you perform. All right, you can also do what's it called? You can also do to sum up all the elements in the array. np dot what? Sum all the elements in the array. So if you do that, you say the sum is what? 78. So add up all the element numbers together, it gives you 78. You can verify that manually. So you can find the product of your array. np dot what dot product of your array, just like product of your array. So which is like what? A and R. So this is your product. So you has multiply everything together. So it's a very large number. So you can do what else can you do? You can take np dot sign of your array. Sign function of your array. So it gives you a new array. And you can do cosine, you can do tangent, and many others. Okay. So and we'll, next class we'll talk about how to manipulate these arrays. Okay. So how to manipulate these arrays, how to use them for some other how to solve so many things with this array, how to join 2 or more arrays together, so and many other things. And all right, so that is where I end the class for today.